So ovum is the largest cell of the body. By repeated division, it assumes a normal cell size of the body. So up to the morula and 16 cell stage, 32 cell stage and 64 cell stage, it is covered by the zona pellucida. So it is a compact layer of cell within the zona pellucida. And then what happens? The cavity fluid enters within the cell through the zona pellucida. So the cell within the zona pellucida, it goes up to the at one pole of the embryo. So there is a cavity appear, and this cavity, it is known as the blastocyst cavity. As the fluid enters within the cavity, the blastocyst enlarge, and cell within the cell is arranged as a outer cell mass and inner cell mass. So the cells of the cell arranged as a outer cell mass and inner cell mass. Eventually, it implanted within the uterine cavity. So what happens once once the cavity is enlarged, blastocyst cavity is enlarged, the zona pellucida is disappear. It disappear around the 7 days. And the cell of the blastocyst cavity, it is known as the blastomere. So then it implanted within the uterine cavity, within the wall of the uterus. So here there is a simple figure: fertilization, 2 cell stage, 4 cell stage and 16 cell stage. Okay, so here we can see there is a outer blastocystic cavity. So outer cell mass and inner cell mass. So outer cell mass of the blastocyst, it becomes a flattened, and it is known as the trophoblast. So outer cell mass, it becomes a flattened, and it is known as the trophoblast. And the inner cell mass is attached to the one pole. So inner cell mass, it is also known as the embryoblast. Now there is a 3 things are there: outer cell mass, inner cell mass and blastocyst cavity. And this blastocyst is begins to implant in the uterine cavity. Now what happens to the inner cell mass? So inner cell mass, the cell lies towards the blastocystic cavity. It is arranged in a single layer and becomes flat. So cell towards the blastocystic cavity, it becomes a flat and arranged in a single layer. So and it becomes a ectoderm, or it is also known as the hypoblast. So development of the embryo during second week. So which are the changes that occurs during the second week? It is the changes in the trophoblast, changes in the embryoblast and changes in the endometrium of uterus. So here we can see outer layer, it is a trophoblast, cavity of the blastocyst, inner cell mass reclining towards the cavity, it becomes a hypoblast or ectoderm. So we use mostly the word it is a endoderm. So cell towards the uterine blastocyst cavity, it is a endoderm. Now the cell lies towards the trophoblast above the endoderm. It is also change its shape. It becomes a columnar and it is known as the ectoderm. So cells of the inner cell mass towards the blastocystic cavity, it forms the endoderm, and above the endoderm, it forms the ectoderm. So here we see the figure in the 2-dimensional view. So assume this it is as it is in the 3 dimension. So imagine that this is a small cricket ball and all this happen into the cricket ball. So outer layer, it is a trophoblast, At one end of the trophoblast, there is the attachment of the inner cell mass, and then inner cell mass is divided into the endoderm and ectoderm. Now what happens? Also, there is a fluid is appear between the ectoderm and the trophoblast. So fluid cavity and fluid enters between the ectoderm and the trophoblast. This cavity, it is known as the amniotic cavity. So amniotic cavity, it is lined by a cell. The cell, it is derived from the trophoblast and that lines the amniotic cavity. Now this cell, it is known as the amniogenic cell. So there is a two cavity of the blastocyst. That roof of the blastocyst cavity, it is formed by the endoderm, then amniotic cavity. Floor of the amniotic cavity, it is formed by the ectoderm, and the roof of the amniotic cavity, it is formed by the amniogenic cell. So amniogenic cell, it is derived from the trophoblast. And what happened to the blastocystic cavity? Now some cells from the endoderm, that forms a continuous line over the blastocystic cavity. Cell from the endoderm that lines the cavity and it converts the cavity into primary yolk cells. So there is a two cavity, amniotic cavity, primary yolk cell. And now the embryo becomes a the disc between the two cavities. It is formed by the ectoderm and endoderm, and surrounding layer it is a trophoblast. So here see the blastocyst implants within the wall of the uterine cavity. So it usually normal site of implantation, it is a posterior wall of the uterus between the junction of the fundus and the posterior wall. So here it is a uterine wall, it lines with the epithelium. So blastocyst gradually embedded within the wall of the uterine cavity. So here there is a transverse section. Here in A2 section, that the blastocyst implanted within the uterine cavity. Now also in which part of the uterine cavity it is embedded. So endometrium. In the uterus there is an endometrium, myometrium and perimetrium. So within the endometrium the blastocyst is implanted. So there is a changes in the uterine wall. It is known as the decidua cavity. Part that lines towards the uterine cavity, it is known as the decidua. So whole the endometrium that changes during implantation, it is known as the decidua. Now there is a decidua capsularis. So the part between the blastocyst and the uterine cavity, it is known as the decidua capsularis. The part between the blastocyst and the deep to the blastocyst, it is known as the decidua basalis, and the rest parts of the decidua, it is known as the decidua parietalis. So here there is decidua capsularis, decidua basalis and decidua parietalis. So here in figure 1, you can see the trophoblast, outer layer trophoblast, and it's begin to implant. So embryo is begin to implant around 7 days and it completes its implantation around 12th day. So in first figure we can see the trophoblast. At the one layer there is an embryonic cell and that is differentiated to the endoderm. Then in the second layer, second figure, we can see the two cavity, primary yolk sac, amniotic cavity, and in between there is a germ disc. This part, the ectoderm and endoderm, it is known as the germ disc. In the third figure, it is implanted within the uterine wall, and we can see there is a uterine endometrium, decidua basalis, decidua capsularis, and peripheral part it is the decidua parietalis. And in figure 4, you can see the further development of embryo. So here, for your roughly idea how the transverse section of pelvic cavity, how the uterus is placed. This is the cavity of the uterine cavity. It is not a large cavity, but it is a slit-like opening cavity. Here, the diameter of the uterus is around 5 into 8 centimeter. So now the formation of the extra-embryonic mesoderm, extra-embryonic coelom, and formation of the amnion and chorion. So here in embryology, these are the new words to you. So here we can see the same as the previous one, amniotic cavity, primary yolk sac, and bilaminar jaundice. That is, and the surrounding extra-embryonic mesoderm. So how the extra-embryonic mesoderm is formed? It forms by the cells lining the primary yolk sac that proliferate, and it forms the extra-embryonic mesoderm. So cell that lines the primary yolk cell, it proliferates and it forms the extra-embryonic mesoderm. So now what happens in the extra-embryonic mesoderm? There is a small cavity appear in the extra-embryonic mesoderm, and this cavity is fused with each other and they form the extra-embryonic coelom. So there is a cavity appear in the extra-embryonic mesoderm. It is known as the extra-embryonic coelom. So in the extra-embryonic coelom, it divides the extra-embryonic mesoderm into two parts. The parts of the extra-embryonic mesoderm that lies nearer to the trophoblast, and parts of the extra-embryonic mesoderm that lies nearer to the yolk sac and the amniotic cavity. So the part that lies nearer to the trophoblast, it is known as the somatofluoric extra-embryonic mesoderm. So it is somatofluoric, trophoblast and extra-embryonic mesoderm. It is known as the cell lies the trophoblast. It is known as the somatofluoric extra-embryonic mesoderm. It is also known as the parietal layer of the extra-embryonic mesoderm. Now the part of the mesoderm that lies the yolk sac, it is known as the splanchnophoric extra-embryonic mesoderm. This part, it is also known as the visceral layer of extra-embryonic mesoderm, or it is known as the splanchnophoric extra-embryonic mesoderm. So the somatofluoric extra-embryonic mesoderm, it extends up to the amniotic cavity, and from here the part that lies the yolk sac cavity, it is a splanchnophoric layer. Okay, now the two things is formed, amnion and chorion. What is amnion and what is chorion? So the part trophoblast and extra-embryonic mesoderm, it is known as the chorion. Trophoblast and extra-embryonic mesoderm, it is known as the chorion. And amnion, the amniogenic cells and extra-embryonic mesoderm, splanchnophoric extra-embryonic mesoderm, it is known as the amnion. So that part that lies the amniogenic cells and the extra-embryonic mesoderm, it is known as the amnion. So the chorion is important because it forms a placenta. So placenta is formed by the chorion. So name, in the placenta the villi are formed. So it is known as the chorionic villi. Is in the extraembryonic mesoderm, there is a extraembryonic coelom cavity is developed, but the cavity does not extend to that parts of the extraembryonic mesoderm where the roof of the amniotic cavity and the trophoblast. Okay, this part is in this part the extraembryonic mesoderm does not exist. So this part it is known as the future connecting stalk. So when we can see this embryo, this part of the embryo is floating in the extraembryonic coelom, and it also becomes by the formation of the extraembryonic coelom. This part also becomes a smaller. So we have seen the chorion, embryon, somatopleuric layer of extraembryonic mesoderm, splanchnopluric of extraembryonic mesoderm, and bilaminar germ disc, amniotic cavity, and this cavity of the primary yolk sac, it becomes a cavity of the secondary yolk sac. By the appearance of the extraembryonic coelom, the primary yolk sac cavity becomes a secondary yolk. So this one yellow one is the endoderm and blue one is the ectoderm. So some cells of the endoderm, it becomes the columnar. Cells of the endoderm, it becomes a columnar. It forms a procaudal plate. There is a rounded elevation in the germ disc at the one end of the embryo. Rounded elevation of the germ disc, it is known as the procaudal plate. So what happens in the procaudal, some cells of the endoderm, it becomes a columnar and it tightly adherent to the ectoderm. So this part, it forms a procaudal plate. By forming the procaudal plate, it decides the head end of the embryo. So it forms a cephalocaudal axis. So the procaudal plate decides which one is the cephalic end and which one is the caudal end. And it appears in the center, so it also decides the axis of the embryo. Now the formation of the placenta. So from where the placenta is formed? Placenta is formed by the chorion. What is chorion? Chorion, it is a trophoblast and somatopleuric layer of the extraembryonic mesoderm. So in figure A, we are going to see the figure A, yellow part, it is the extraembryonic mesoderm. Then this is the layer of the trophoblast and then there is a deciduum. In figure B, we can see there is a yellow part, it is the extraembryonic mesoderm. Then this layer of the cytotrophoblast. So the trophoblast, it is divided into cytotrophoblast and syncytiotrophoblast. So trophoblast, it divides into the cytotrophoblast and syncytiotrophoblast. Now what happens in the syncytiotrophoblast? The syncytiotrophoblast, it loses its cell boundary. So we can see only cytoplasm is there and nucleus is there and it divides. So layer of the cytoplasm with the multiple nucleus, it forms syncytiotrophoblast and cytotrophoblast. So in the syncytiotrophoblast, there is a small cavity is appears. In figure C, you can see the small cavity is there. And in figure D, the small cavity is united and it forms a large cavity. So this cavity, it is known as the lacunae. So once again I am telling you, keep in mind we are seeing this in the 2D. So you imagine it into the 3D outside the extraembryonic coelom. These all are happening. So there is an enlarged lacunae. So there is a lacunar space is there, and in between the lacunar space there is a syncytiotrophoblast. Okay, so the space between the two lacunae, now it is known as the trabecula. So here one is the trabecula and lacunae. So below to upward we can see extraembryonic mesoderm, cytotrophoblast, lacunae, trabecula, and in the uterine endometrium, that is a deciduous cytotrophoblast. Periphery to the cytotrophoblast, it is a lacunae and trabecula, and outside to it, it is a decidua basalis. Now come to the figure. The figure 3, what happened? In the lacunae, it filled with the maternal blood. So what happened? From the decidua, the blood vessels are eroded and it enters into the lacunae. So lacuna is filled with the maternal blood. In figure H, you can see there is a layer of the cytotrophoblast. Some cells of the cytotrophoblast enter in the center of the trabecula. Cytotrophoblast enter into the centers of the trabecula. So here there is a lacunae filled with the maternal blood, then trabecula, and then cytotrophoblast. These three structures, it forms the primary villi. Now what happens? As the cytotrophoblast goes upward, center of the cytotrophoblast, some cells of the extraembryonic mesoderm that enters into the cytotrophoblast. The structure of the secondary villi: trabecula, syncytiotropoblast, lacunae. First one is the lacunae, then syncytiotropoblast means it is a trabecula, then cytotrophoblast, and then extraembryonic mesoderm. So these three parts that forms the secondary villi. And now what happened? In the figure J, in this figure, there is a formation of the blood vessels in the extraembryonic mesoderm. It forms a tertiary villi. So here is primary villi, secondary villi, and tertiary villi. So formation of the blood vessels within the extraembryonic mesoderm, that forms the tertiary villi. So there is a circulation is established between the maternal side and the mother and fetus through this membrane by the diffusion. So tertiary villi, it is consists of the mesoderm with blood vessels, then cytotrophoblast, then trabecula, and then lacunae. Okay, so there is a villi, primary villi. It is known as a primary chorionic villi because it forms from the chorion. Then the secondary villi, it is a secondary chorionic villi, and tertiary villi. This white part below, it is a uterine cavity. This one is the uterine cavity. So the part first, the chorionic villi develops all around, all in the decidua basalis and decidua capsularis. But what happens? As the embryo enlarges due to the pressure, there is a disappearance of the villi in the decidua capsularis, and this uterine cavity is almost obliterated, and the decidua capsularis is fused with the decidua, fused with the uterine wall. So the villi develops in the which part? The villi develops in the decidua basalis. There is a tertiary villi is formed. Now what happened? Here we can see the extraembryonic mesoderm. Then this one is the cytotrophoblast. Here it is trabecula and lacunae. Now the cells of the cytotrophoblast goes at the tip of the villi and it forms a layer at the decidua basalis. Between the decidua basalis and villi, it forms a single layer. Now these four parts of the villi, it is known as the cytotrophoblastic shell. is formed, and this villi forms. It is known as the anchoring villi. So villi, primary villi, secondary villi, tertiary villi, and now it is a anchoring villi. So it attaches. So there is a layer of the cytotrophoblast between the decidua and the villi. Outside to inside, it is a trabecula, cytotrophoblast, and extraembryonic mesoderm with blood vessels. So that's how the placenta is formed. Now the placenta, then we can see from the fetal side. This one is the fetal side, and this, when we see from the fetal side, it is a smooth part, and when we see the maternal side, it forms a lobe, and there is a 50 to 20 lobes in the placenta, and it is known as the cotyledon. So what happens when the embryo goes inside? It erodes the decidual part. So some part of the decidua that extends inside, and it goes inside, and it forms the lobules, and these lobules, it is known as the cotyledon. So when we see it from the maternal side, it is a rough area, and from the fetal side there is a smooth area. And what happens once the villi is formed straight? There is a side branching are arising from the villi. The side branches are formed as a same as the primary villi, secondary villi, and tertiary villi. So space between the two villi, it is a lacunae. So lacunae is almost filled with the villi. So the villi grows as a side branches from the tertiary villi or acunae, and it fills the intervillous space. So what happens? First there is a diffusion between the intervillous space and the lacuna and the villi. So there is a thickness of this membrane, placental membrane. It is around 0.5 mm, and as the embryo goes later, it reduces up to the 0.025 mm. So the villi blood vessels is almost in contact with the syncytial trophoblast, and there is a diffusion between the maternal blood and the placental blood. In the placenta, there is a 2 artery and 1 vein. So vein carries oxygenated blood and artery carries deoxygenated blood. And from the maternal side, the artery eroded is in the lacuna, and they pour their blood in the lacuna. So that's how the placenta is formed. Here again there is side branches of the villi, how it fills the intervillous space.